So, read through the example. We've got 4 items taken at random from a box of 12 items. The 4 items are inspected. It could be some sort of quality control procedure. The box is rejected if more than one item is faulty. There are 3 faulty items in the box. What's the probability the box is accepted? So, probability, we're looking for a fraction. The bottom number is the no restrictions number. The top number is, well, we're interested really in the box being accepted. So how many ways the box being accepted can happen. That's what we are looking for in our fraction. Which one of these is the easiest one to work out? The no restrictions one. Right, I would like somebody I haven't heard from so far. I've heard from you. Yes. Yes, that's right. There are 12 things in the box. We want 4 of them with no restrictions. That is 12, choose 4. Does anybody have that as a number?
495.
495, yeah, good. So that's the bottom number in our fraction. The box being accepted. Okay, what are the conditions? Is it a question or an answer? Do you mind giving someone else a go? Okay. Thinking about how we can do this, first of all. Catherine.
Would it be like you've got the option of 4 items being good and then an option of 3 items being good and one being bad?
Yes, okay. So let's say the first thing you said, 4 items being good, or 3 being good and 1 being bad. So let's just put a key over here. G is a good item, B is a bad item, and we can either have 4 goods or 3 goods and a bad.
Yeah, so if there's 3 faulty items in the box, so surely he could pick out 3 bad.
Could do, but we're only interested in the moment in how the box could be accepted. So yeah, the only way the box can be accepted is if we have all 4 goods or 3 goods, no more than 1 bad. So this first one here, 4 goods. How many ways are there of choosing 4 good items? And again, somebody I've heard from not very much, please. Liv. There are 9 good items here because there are 3 faulty ones, and it's choosing 4 of the good ones. So yeah, 9 choose 4 is correct for that. Then over here, 3 good ones and 1 bad one.
9 choose 3.
Yep.
You do 9 choose 3, take 4.
Yep.
And then you do 3 choose 1.
Yeah, that's right. You're choosing 1 out of the 3 bad ones, 3 out of the 9 good ones, and that's the times, and the or is an add. So, I haven't got all of these numbers broken down as numbers. I think somebody earlier on there said what 9 choose 4 was. 1, 2, 6. Okay, hope someone's agreeing with that. 9 choose 3. 252. 3 choose 1 is going to be 3.
No, the whole thing.
Oh.
Oh wait, no, sorry.
So what's that one?
3 times 84 is 200.
84.
So it's
Okay, so it's
sorry.
252 there together. Okay, which gives us 300 and because we're timesing by 3. Yeah, yeah, 378. So that's the top number of our fraction. There are 378 ways the box can be accepted out of 495 possible pickings. I've got down here that's, I'm not sure whether it's exactly equal to or roundabout equal to 0.76 as a decimal. So it's about a 76% chance. Okay, so it's about a 76% chance of the box being accepted. Okay, the next one we are going to look at is, it links in a bit with some decision maths that you'll do next year. We're going to be looking now at diagonals in polygons. So, next example. The diagonal of a polygon is defined as a line joining, Can't start joining today. Go on, what's going to come next? How can we define a diagonal of a polygon? It's a line joining...
Another line. Opposite words.
Two corners.
I haven't quite heard a perfect one yet.
Two right
Have a think. Come on, what will it join? And what condition have you got to put on it? That's not enough.
The opposite angles.
I know what you mean. Opposite's a bit of a not quite right word, but you're going the right way.
It makes like
Go on. Yes, ones that aren't next to each other. Okay, that's right. There's a line joining any two non-adjacent I've got down here, which is exactly the same as what you said. Non-adjacent corners. Because if they're adjacent corners, it's not a diagonal, it's an outside line on the shape. So we have here, question is, how many diagonals are there?
watch it out.
In part A, a pentagon. Part B, a hexagon. And what do you reckon part C will be?
Heptagon. No, what? Septic. I don't know what we call it. Heptagon.
No.
No, it's a 7.
An n-sided shape, or an n-sided polygon.
Oh. Crap.
Okay? Which will then sort of give us the rule for any of them. Right. To start with, let's actually draw a pentagon. Hasn't got to be a perfect regular one or anything. But there we go. There's a pentagon. It's a 5-sided shape.
That's lovely.
Choose a corner. And what have I got to do then to get a diagonal? I've got to choose...
To a non-adjacent.
Yeah, I've got to choose another corner. So I'm going to choose that one, for example. That would be a diagonal. Can't choose that one because that's an adjacent corner. That would just give me an edge. I can choose that one over there. And the other ones I can do are going to be that. Okay.
Sign of the devil.
So, you can just count up in there how many red lines there are. How many red lines are there?
5.
5. Yeah, the answer is there, 5. There are 5 diagonals. Okay, that was fairly easy to do, just by counting. The next one, the hexagon, is a 6-sided shape. And again, there are various ways of doing it. We didn't do that one in a particularly organised way. Let's try and do this in a slightly more organised way. If I start off at that red marked corner, bottom left, how many other corners can I go to?
3.
Okay. How many corners could I start at?
6. So it's 6 times 3. I think.
So you're saying it's 6 times 3?
Well, so it's 3 lines. So oh wait, no, because there are lines that are joined. So it's not 6 times 3.
6 times 3 is important, but what do we have to do with 6 times 3? Because if I do those 3, and then from here I do another 3, which are there, and here I do I'm not going to do another 3.
It's a combination because some lines can be repeated.
Yeah, because effectively, if I did 3 lines coming out of everywhere, what am I actually doing?
You're going to go over
You go
some of
over
the same
about
lines.
Some of the
Sort
same lines.
You go over about 6 lines.
About 6 lines. Can we be a bit more precise?
You go over exactly 6.
Yes. I would do every one twice. Okay? Because they've each got 2 ends. Okay? So if I thought about 3 coming out of everywhere, I'm missing up there. They all got 3 coming out of them now? Yeah, it's not 6 times 3 is the number of ends of lines. But each line has got how many ends? 2, yeah. So it was 6 corners with 3 lines coming out of each of them, but then you are double counting. So we would need to do that. So we get there eventually 9 diagonals there. That's one way of doing it.
How would you work that out there? Oh,
Well, that's what we're going to look at next. Okay? Because now we're going to look at the n-sided version. the n-sided polygon. How many corners? Let's just think, yeah. How many corners are there we could choose from? N. For any line, how many corners are we choosing?
N over
For each
no,
line,
N
how many corners are we joining up?
minus 2.
2.
Oh,
For an n-sided polygon, how many corners are you joining up? The start corner and the end corner.
okay.
It's 2. So if you do that, you are choosing, looking at all the possible pairs, basically all the possible starts and finishes.
Is that
Um,
n choose 2?
That's going to be n choose 2, yeah. But there is something we talked about at the beginning which we haven't taken account of.
Like
Some
double
line.
lines.
It's not the double.
You don't want to make
Shapes.
edges.
Yeah, that's right. We have not here ruled out the edges, because they could have chosen, for example, those two, which would give us an edge. So I need to subtract the ones I'm not allowed, which is the edges.
It's 2 lines.
How many edges are there on an n-sided shape? N. Yeah, okay. So that will give you what you need.
Oh, is that
And if you just check, so if we were doing the 5-sided one, that will give us 5 choose 2, take away 5. 5 choose 2 is 10. 10 take away 5 is 5. That does work. If we're doing the 6-sided one, it'll be 6 choose 2, take away 6. I don't know what 6 choose 2 is.
15.
15.
9 by lines.
Okay, 15 take away 6, that gives us 9, and it does work. Okay, right. We're getting towards the end of this. So, I think the best way for this chapter is lots and lots and lots and lots of examples. So, the next question we're going to look at will be, I think, in a new video clip, because this one's 12 minutes long.